Hello pre-calculus students. In this lesson we are going to solve actual equations that involve logarithms, and up to this point we've learned how to convert back and forth between logarithms and exponential form. We've learned how to apply laws of logarithms like the product rule, the quotient rule, the power rule, the change of base rule. And now in this lesson we're going to kind of incorporate all of that and some prior knowledge to solve some problems. So let's start with a straightforward one. This one says log base 2 of x equals 5. And one of the tools that we have at our disposal is just being able to convert this into exponential form. So by converting this into exponential form, we get base 2 to the 5th is equal to x, and that means 32 equals x. Okay, and that was straightforward enough. Well, let's try another example that's a little bit more complicated. Okay, so in this next example we have an equation log base 4 of 1 minus x equals 1, and we'll apply the same step as we did before. Convert this into exponential form. It's 4 to the first equals 1 minus x. Okay, so in exponential form the expression inside the log comes outside, base exponent. So that means 4 equals 1 minus x. Subtract 1 from both sides. 3 equals negative x. Negative 3 equals x. And there you have it. Solving for logarithmic equations using the rule of converting this into exponential form. Now in our next example we are going to look at some scenarios with just a little bit more expressions on the outside. Okay, and so let's go to that. Okay, so in this example we're asked again to solve for x, but this time it's not a logarithm, it starts with an exponential form. And traditionally we've done this before using graphing, but we want to be able to do this using algebraic methods so that if we needed to get an exact answer we could. Okay, so first thing I'm going to do is subtract 7 from both sides, so negative 3 e to the negative x is equal to negative 5. Divide both sides by negative 3, so e to the negative x equals 5/3. Take the natural log of both sides. Natural log of e to the negative x equals natural log of 5/3. Then on the left side here apply the power rule. So the exponent can go into the front. So negative x of negative x times natural log of e equals natural log of 5/3. Okay, and we've learned from previous knowledge or from previous examples that natural log of e is really equal to 1. Okay, and if and we can also just plug this into a calculator and it'll give us 1. So that'll give us negative x is equal to natural log of 5/3, and x is equal to negative natural log of 5/3, and I get that by multiplying both sides by negative 1. So if I needed to get an exact answer I could just stop right here and just put a box around it. If I wanted to round, I can type this into a calculator and I'll get x is approximately equal to negative 0.5108. Okay, so the first expression is the exact value, and the next one, this is 4 decimal places. And there you have it, solving algebraically for an exponent when the exponent is the variable. I have an equation now. 3 times the natural log of x minus 3 plus 4 equals 5. And we're going to follow the same process again. The goal here is to isolate the natural log so that we then can convert it into exponential form and use that to solve our equation. Okay? So my goal is to get natural log by itself. So I can subtract 4 from both sides, and that will give me 3 natural log of x minus 3 equals 1. Then I can divide both sides by 3. So natural log of x minus 3 equals 1/3. And now that I have it in this form, what I can do is convert it to exponential form. And keep in mind that natural log is really log base e. Okay? And I'll write this extra step in here for those who aren't quite familiar with natural log yet. Okay. Now converting this into exponential form, it becomes e to the 1/3, this is my exponent, is equal to x minus 3. That means e to the 1/3 plus 3 equals x. And if I needed an exact value, I could stop right here. This would be it. If I am asked to round it to the however many digits, let's just go with the 4 digits, so we can actually just type this into a calculator. And so this gives me approximately 4.3956 is approximately equal to x. And that does it for these sets of examples. In the next video, we are going to look at some much more complicated examples that apply the product rule and the quotient rule.